So let's look at some of the integrity attacks that you could be a victim of. They can be summed up in several different categories, but the first one I want to talk about is referred to as a data frame injection. This is where we go through and we construct and send out forged wireless frames on the network. Another type is referred to as a data replay attack. This is the concept of capturing wireless data frames and then being able to modify them offline and replay them later. We also have web injection, which if you've been around wireless at all, you probably understand what this is, but basically we construct and again distribute forged web encryption keys. Another type of attack is referred to as an IV replay attack. Now, I couldn't come up with any icon when I searched for IV except for a medical icon, so hopefully you'll bear with me on that one. But this type of attack is implemented by deriving the key stream by sending plain text messages. Since the IV, remember that's short for initialization vector, is transmitted with the packet in plain text, weak IVs are very easy to detect. And given enough time and traffic, we can actually recover the entire key. Another type of attack is called a bit flipping attack. Now this is where the attacker sniffs a frame on the wireless network. The attacker transmits the modified frame, the access point accepts the modified frame, but the destination receiver, when it goes to decapsulate the frame, the checksum fails, and the receiver generates a predictable ICMP error. The attacker just simply sniffs the network LAN looking for the encryption error, and upon receiving the message of the error, the attacker is able to derive the key stream, which is the same thing we do with the IV replay attack. Another type of attack is the EAP replay attack. This is where we go through and capture packets during the EAP authentication process and just simply inject it back into the network to gain access. It's kind of the same concept when it comes to radius replay. This is where we go through and capture the communication channel between the access point and the authentication server. Remember we talked about radius servers? We can later replay that interaction to see if we can gain access. And believe it or not, there are actually what they refer to as wireless network viruses. Now these aren't viruses that target computers and nodes. It actually targets access points. One of the most popular ones is called Chameleon, which when it attacks an AP, it doesn't affect how it works, but instead it's able to collect and report credentials of all other Wi-Fi users who are connected to it. And if it finds after it was done, or if it found a roadblock that it couldn't access that information, the virus actually sought out, you ready for this one, other Wi-Fi access points that it could connect to and affect. So your neighbor's access point could actually infect your access point. As far as confidentiality attacks are concerned, Wi-Fi opens us up to several of these. One of them being obviously honeypot APs. This is just simply where an access point SSID is set up to be the same of a legitimate access point. There's also session hijacking. This is again very similar to what we see with the wired network, but it's where we manipulate the network so that the attacker's host appears to be the desired destination. Also, obviously, traffic analysis. This can tell us quite a bit about the network infrastructure. Also, eavesdropping. This is again where we're just going to capture and look at traffic to see if we can obtain any type of potentially sensitive information. Masquerading is another one. This is where you put on a costume and you run around the office. No, never mind. This is actually where you pretend to be an authorized user to gain access to a system. We also have the man-in-the-middle attack. Again, this is simply just a network, but instead of wires, we use wireless. If you're not familiar with the concept of man-in-the-middle, I recommend going back and watching our sniffing course. Another confidentiality attack would be obviously cracking web. Again, just by capturing data, we try to recover the web key using either brute force or an FMS cryptanalysis. And of course, probably the most notorious is the evil twin access point. Yes, evil twin. This is where you basically pose as an authorized access point by using the same SSID, and hopefully users hook into your access point mistakenly. Now we also have availability attacks. Obviously, if someone steals your access point, you're going to have a problem with availability, as well as any type of denial of service attack. If I go through and send forged authentications or associations from random MAC, attacks, I'm going to end up doing an authorization flood. Another type of availability attack would be a disassociation attack. This is where we basically go and just totally destroy the connection between the client and the access point and make the access point totally unavailable. Another type would be a deauthentication flood. This is where we flood clients instead of the access point with forged deauthentication or deassociation to disconnect them from the access point. Another type is ARP poisoning. Again, this is exactly the same thing that we do on the wired network. It's also one of our first steps in performing the man-in-the-middle attack. We also have routing attacks. This is where we goof up the routing tables, or maybe even try to poison the routes and distribute that information throughout the network via the access point. We also have EAP failures. In this case, we look at valid 802.1x EAP exchanges and then send the client a forged EAP failure message, and again, they would disassociate. We also have what they refer to as the tricky power saving attack. This attack is just basically tricking the access point into believing that the client is in sleep mode. Another type is beacon flooding. Now, what the attacker does here is, in order to take away the availability of the access point, is they go through and generate hundreds and hundreds of thousands of counterfeit 802.11 beacons and distributes those in the air, and it makes it harder for the client to find a legitimate access point. And finally, we have the TKIP MIC exploit. This is basically where we go through as an attacker and generate a bunch of TKIP data that exceeds the target's MIC error threshold. MIC is short for message integrity check. And by exceeding that threshold, we actually shut down the access point. We also have authentication attacks. These type of attacks allow us to do things like steal the identity of the person logging in, as well as possibly going through and cracking either PSK, as well as possibly also cracking VPN login information. And while we're talking about cracking, we might as well look at cracking domain login credentials. Most of these are going to be done with brute force attacks, or possibly using some type of dictionary tool. We also have something called password assumption, where the attacker just goes through and by capturing identities, he just continually attempts using 802.1x authentication to try to guess the user's password. And one of my favorites is obviously the app login theft. This is where we capture users' credentials from clear text application protocols. Oh, you know, because everybody uses different passwords for different apps, right? Typically we use the same password for the app as we do as our login credentials, as well as to gain access to our wireless network. You didn't think about that one, did you?